There's a particular acoustic quality to buildings made from rammed earth. So, in this explainer, which draws from the book The Memory of Rock Understanding Rammed Earth by Gokul Salvadi, we're going to explore what creates that distinct sense of quiet and the physics behind that experience. When you walk into a rammed earth building, the very first thing you often register isn't the light or the temperature, but the sound. Or maybe more accurately, the sudden change in sound. It's not a dead artificial silence, the kind you'd find in a soundproof studio. It's more of a qualitative shift. The noise from outside is still there, but it's softened, made more distant. The sharp edges of sounds just seem to be smoothed away. And this leads to a pretty fundamental question about the whole experience. It feels different, sure, but what's the actual underlying reason for that feeling? That subjective feeling of calm, well, it has an objective cause. It comes directly from the physical properties of the walls themselves and how they interact with sound waves. So to really understand that interaction, we have to start with the basics. What sound actually is and what happens when it meets a surface.
At its core, sound is just a form of energy. It's a wave of vibrations traveling through the air.
So when one of those sound waves hits a barrier, like a wall, its energy can do one of three things. It can reflect, which means it bounces back into the room. It can be transmitted, meaning it passes right through the wall. Or it can be absorbed, where the material itself traps the sound energy and converts it into a tiny amount of heat. Now, for rammed earth, the way it manages that sound energy isn't through just one single property. It's actually three inherent mechanisms all working together. The first one, and probably the most straightforward, is just sheer mass. A typical rammed earth wall is incredibly dense and heavy. Think about a lightweight wall, like a simple office partition. It'll actually vibrate in sympathy with a sound wave, almost like a drum, and let that energy pass through. A massive wall, on the other hand, resists that vibration. For a sound wave to move it, it has to expend a huge amount of its energy, which just gets absorbed into the wall's mass. The wave essentially just dies inside the wall. But mass isn't the whole story. Unlike poured concrete, which is pretty much homogeneous all the way through, rammed earth is built up in these compacted layers, and that layered structure is really significant acoustically. See, each layer of rammed earth has tiny little variations in its density. This creates boundaries between the layers. So as a sound wave tries to travel through, it has to cross these boundaries. And every time it does, it loses a little bit of energy. This process is called attenuation, and it just progressively weakens the wave as it moves through the wall, layer by layer. Okay, so the third mechanism operates at the surface of the wall itself. If you were to run your hand across it, you'd feel this fine-grained, slightly open texture. That texture, with all of its microscopic pores and irregularities, is really good at dealing with high-frequency sounds. The wavelengths of these sounds are really short, so they get physically trapped in that surface texture instead of just bouncing back into the room as echoes or reverberation. So if we look at how this all comes together, we can see these properties address the entire sound spectrum. First, you have the sheer mass of the wall, which handles all that low-frequency energy through absorption. Then the internal layers dissipate the mid-frequency sounds, as energy gets lost at each boundary. And finally, that surface texture is incredibly effective at trapping the short wavelengths of high-frequency sound. It creates this comprehensive system, not through some complex engineering, but just through the inherent nature of the material itself. So this brings us back from the physics of the wall to the actual experience of being inside the space that it creates. What's the real effect of these three mechanisms on the acoustic character of an interior space? Well, in a typical room with hard, reflective surfaces like concrete or glass, sound bounces all over the place. Voices echo, they build on each other, and you might find yourself having to speak a little louder just to be heard clearly. Because rammed earth walls absorb so much of that sound, that effect is really diminished. The sound travels from the source, it hits the wall, and it largely just stops. It means conversations can happen at a normal volume because the room isn't fighting you. And there's another difference, and it's in the quality of the silence itself. In a concrete room, the absence of active sound can have a sort of ringing tension to it because the walls can resonate, holding on to energy. In a rammed earth room, the silence feels more complete. It feels deeper because the walls aren't storing or reflecting that residual energy. This quality of stillness, it's hard to measure with a decibel meter, but it's a very real part of the experience. The room itself feels like it's at rest.
and that contributes to a genuine sense of quiet.
The acoustic performance of rammed earth isn't some kind of add-on. It's just an inherent quality of the structure. The very same wall that's holding up the roof, regulating the temperature, and controlling humidity is also creating this unique acoustic environment. And it does it all passively and permanently. This integration of function is really the hallmark of the material.